So hello and welcome friends to our channel Intro Make, where we discuss about basic mechanical engineering concepts and many other things which are related to the automation field. So guys, we have started our new series regarding special mechanical devices, and today we will discuss about part feeding system. So without wasting time, let's get started. Now what is the part feeding system which is used in automation? So in case of automation, there are different processes and different types of mechanized feeding devices are used frequently. So the main purpose is we will be having the input part, and that will be in a huge quantity. So we need to feed that to our system in a proper feed rate, in a proper orientation, and so that the cycle time can also be maintained. So how the part feeding system look like? So this is a typical part feeding system, and the important components are first the hopper, so through which we will add our input parts, then the bowl feeder, which we can see the heart of the system. We can have the linear feeder or a singling system, then the bottom mechanism, the base plate and the support structure. So these are kind of mounting things. So these parts are very important when we say the part fitting system. So we have a hopper system, then the vibratory feeders. So in feeders we can have different types as uh, vibratory feeders, then we have centrifugal feeders, step feeders, and then the linear conveyor system, that is nothing but the singling system. So let's check what are these parts. So first is the hopper system. So as I discussed, these hoppers are used basically for store the parts for further processing, and we can see over here the hoppers can be having different shapes and size. Here we can see the hopper, we are having the input, and then at the bottom we have the feeder system which is vibrating and then transferring the material. So the hopper feeders are utilized to prevent the overloading of the bowls, because if we are directly putting the material into the bowl feeder, it may get overloaded. And these hoppers will come in different styles as straight, elevated, inclined, and we can change the design according to our application also. So this is the first component we can say as the hopper systems. Then we have the vibratory feeders, as I explained. We can see in this video here how they are getting separated out. These bolts are there, it is getting vibrated, and each bolt is getting separated out so that we will get a bolt at a constant feed and in a proper required orientation. So here again one example, we can see these circuits are there and they are getting vibrated, and we can see with the arrangements they are getting oriented in proper direction only. If they are not in proper direction, they will again fall into the feeder and they will again come into the system. So that is important thing. Like we can see the most common types of automated feeders are these vibratory feeders, and they are specially tooled and they are mounted on the vibrating phase. So this is the bowl as we saw, but how it is vibrating, it is having some base, and that is powered by electromagnetic or the pneumatic drive. So it will be having some drive and a controller which will be controlling its voltage and the frequency, and according to that it will be vibrating, it will be separating the components, and we will be getting the components. So the key feature of the vibrative feeder bowls is sorting and orienting the bulk parts more rapidly with efficiency. So as we saw in the video also, so it is sorting the part and it is keeping the part in a proper orientation. So whenever there is a huge automation where the cycle time is very crucial, so in these applications, these feeders are very plays a crucial role. So this is a vibratory feeder. Now let's check another type of the feeder, which is centrifugal feeder. So here you can see in the video the centrifugal feeder. So it will be operating on a motor, and you can see there is a disc which is rotating and separating out the parts are getting fed to the feeder. And here the principle is it is getting rotated with the motor, it is not getting vibrated, and we are getting the outputs. Again, in this system also you can check it is getting rotated and how uh, the parts are getting separated. So it is silent, it is vibration free, and we can see the it is referred to as a rotary feeder, as it is used to feed components which can be processed at very high speeds. So it is a large rotating disc and driven by the motor. So these are the centrifugal feeders. Then we have step feeders. So you can see in the video we are having the steps, and as names suggest, the step feeders use elevating plates, referred to as steps, to collect the components and parts from an integrated hopper bin. So you can see the hopper bin, they are getting collected into the steps, and then they are getting oriented, and you can see if they are not properly oriented, they will be returned to the hopper bean by the gravity slide or similar method of conveyance to repeat the process. So here you can see they are getting dropped again, which are not properly oriented, so they will be coming back again into the feeders. So the key design feature of the step feeders is lifting single rows of bulk parts from hopper by the steps. So they operate very quietly and are vibration free. So now the linear conveyor systems. So here we can see from the feeder we are getting these parts, and then we can see they are coming at the outputs outlet, and here now we require one part at a time. So this is called as a singulation. So you can observe it is taking one part at a time. So this is called as linear conveyor system, which is at output of the conveyor, and they are used to gather and convey parts and components that have been sorted and oriented from the feeder bowl, and then move them downstream to the further processing. So as we saw in this system, so the feeder will first sort and orient them, then this system will come into picture, as it has to take these parts to the main system, to the downstream, for further processing, whatever processing we want to do. So this will include different escapement features, different singulation features, as we want to have only one part. So conveyor linear feeder systems are designed to provide the consistent flow of sorted and oriented parts to an escapement device at timed intervals for efficient removal, right? So that is what we saw also over here, and different kind of systems we design according to our requirement. Here we can see we will get two singulated parts at a time. So that is how we can design these feeders also. So this is all about the overall system of um, automated feeding arrangement, what are the different types, and how they can be used. So in our next session, we will see what are the different selection parameters, and which parameters we need to consider. So if you have any doubts, please do write into the comment section and we can discuss over there. Until then, keep intro making. Thank you for your patient listening. Thank you.